So for this next step in the workshop, we're going to put everything that we've seen so far in terms of contracts together. And so we are going to make a contract that now acts as a factory, a token factory. So it's going to let us, let whoever calls it deploy an ERC20 token. But we're going to add an extra feature, and that is, right, once we've deployed our token, we want other people to be able to buy and trade it because it's supposed to be a meme coin, and so you want to have as many people as possible get into it. So to do this, we're going to need to deploy Liquidity on a decentralized exchange so that anybody then can go to the pool and decide that they want to spend some they want to trade it for some other token, right? So we've got our pragma here that does not change. We've given the contract a title, we've got a license, and so on and so forth. Then we're going to import interfaces. So we've got them in separate interface files here. You don't have to do this, right? But this is nice when you don't want to have your contract, right? When the interfaces are kind of long and you don't want your contract to be filled with interface declarations, then you can just put them in a separate file, like I just did here under the folder interfaces. And then we're going to be able to import them and use them with other contracts. Right. Then we've got a few constant and immutable variables, our ERC20 implementation. So that's going to be our blueprint token contract that we've deployed already. Quickswap router is Quickswap, so that's the decentralized exchange that we're going to be using. That's on Polygon, and it's based on Uniswap v2. So we'll be using the Uniswap v2 interface a little bit further down. And owner share is to decide how much of the supply is going to go back to the token deployer. And so there is a maximum, so you can't claim more than, right, this is in BPS, and you can't claim more than 90% of the supply because you've got to leave some to put in the liquidity pool. Right. Next, we've got an event declaration. And so this is going to be used when we are done deploying our token. We're going to emit an event. Right, and events are very useful for indexers if you want to run some stats on your contracts, or it lets people fetch additional information about state changes that your contract has done directly from the chain, right? And so every time we deploy a token, we're going to create an event that is going to broadcast the new token's address and the total supply. Right, and then here, this is our Uniswap interface. So it's just only one function that we're going to be using to add liquidity to an ETH pair. Of course, we're going to be deploying on Polygon. So here, the pull token is going to be taking on the role of ETH. And those are just the different parameters that this function expects. And so we're defining them here as an interface so that we can then call the Quickswap router contract here from within our contract. All right, so on to the actual functionalities. Here we've got deploy. This is our constructor. This is the same as the token factory that we've seen before. Right? We just want to make sure that we set the address of our ERC20 blueprint as a variable that we can access anytime later. All right, next, so this is an internal function. We've got a couple here to create the token. All right, so this is similar to what we used to do to instantiate new instances of the blueprint contract ERC20. So here we've got an internal function that is going to let us do that, right? Create a token. And then we've got another one to add liquidity, right? So we'll get back to this in an instant, but let's get back to our main function now, which is going to be deploy token. So it's going to be external, right? We want anybody to be able to call it. This is permissionless. So anybody can call this function. Once we've deployed the contract, anybody can call the function and deploy a token and add liquidity for it. So our agent is going to be the one calling this contract, but technically anybody could do it. We could implement some access control here using the ownable module and restricting access to this function to the owner of the contract, but there's no real security reason, right, to do so. The contract's not custodial, so we're just going to leave this function open. And then we want to declare the function as payable. The reason for this is that we're going to be adding liquidity, right? And a liquidity pool is a pair of tokens. And so we're going to pair our new deployed memecoin with the ball token, right? With the native token on the Polygon chain. And so to transfer this to the contract, right, it needs to be a payable function. Right. So deploy token, then those are the standard argument that we are going to use to deploy our ERC20, the name, symbol, decimals. Total supply, when we mint the token, if we want to give the total supply a funny number, right, then we can specify this here. And then we've got the owner share. So this is how much of what proportion of the supply you want to keep to yourself, and everything else is going to be sent to the liquidity pool. And burn owner is whether you want to relinquish ownership of the ERC20 contract after deploying it or not. So if you do not do this, you would still have the option, for example, to mint more token afterwards. All right, so this is our this is going to be our main function. We've got docstrings here, and then we do a number of checks, right, using assert to check that the message value, so that people are actually sending ETH. Technically, this should be pull here. Owner share, so we can't claim more than 90% of the supply because we got to leave some for the liquidity pool, and then total supply has to be greater than 0, right? So those are just some sanity checks. We could do a bit more, but this is just for an example, so we won't worry too much about being thorough. All right, next, we are going to start by deploying our new token, right? And so we're calling our internal function here create token. That we went over right before. So it's just passing on the name, symbol, decimals, and so on to our blueprint and deploying a new instance of it. So we get a new contract, a new token based on the blueprint, and we log an event for this, right? So this is going to be what's going to broadcast the event that we've defined earlier here. All right, and then once our token is deployed, we are going to mint some of it, right? So the owner amount here is going to be the total supply that we've minted already, divided by the owner share. Right, and so that's going to be the amount that's going to go back to whoever deploys the token, and then the rest is going to be whatever's left over, right? Total supply minus owner amount. That's going to be put in the liquidity pool on Quickswap, right? So we're going to mint those tokens from the supply. So we're going to do an external call, right? And here, whenever you are going to call a contract in Vyper, right, a contract that is an external contract, and you're going to modify the state of that contract, you are going to be doing an ext call, right? So it's going to be made explicit, so you know exactly, right, that this contract that you're calling here is potentially going, right, it's not a view function, so it's going to have some effects. Right, so this is so that, right, you are certain that, right, you know what you're doing. Otherwise, you would have a static call here. Right, so here, new token is the token that we've just deployed. That's the address, and then we're using our ERC20 interface here so that we can mint the owner amount to the sender, to whoever is calling the function. And then whatever is left, we are going to be minting on to the liquidity pool. Next, if the owner is burned, we are going to renounce ownership, right? So we're going to set the address of the owner of the ERC20 contract to address 0, and then transfer ownership to the caller. Otherwise, if we wish to retain ownership of the ERC20 contract. And then once we've dealt with ownership, we are finally going to add liquidity to the Quickswap pool. And so this is going to call here our add liquidity internal function that was defined here. So this is add liquidity. First, we need to approve the token, right? Because when we call add liquidity, the Quickswap router contract here is going to take the token out of the contract that we're dealing with now, out of our deployer contract, right? Remember, we've minted part of the supply to the caller here, and the rest of the supply here, right? It's minted to self. So it's minted to this deployer contract right now. So the contract is going to be owning a number of tokens, and those tokens are now going to need to be transferred to the Quickswap liquidity pool or via the Quickswap router. Right, so the router needs to be approved to take ownership of those contracts, to transfer them on the behalf of this deployer contract. So this is why we approve the Quickswap router for the amount of tokens. And then next is our external call onto the Quickswap router to add liquidity. Right? And so it's going to be token. Right, so that's the address of the new token that we've deployed, the amount that we want to add to the liquidity pool. Those are min amounts out. So this is mainly useful if you're adding to an existing pool. We're going to disregard this for this example. Here is the address that we want to send the LP tokens that are going to be minted after we add liquidity, right? We don't want the tokens to be sent back to the deployer contract. We want to send them on to the caller, right? So that once the caller is done calling deploy token, they're going to get part of the token supply, and they're going to get the liquidity pool tokens. That's just the deadline for validity, and then value is going to be the ETH amount, right? So that's the msg.value from this function here that's payable, right? And we're sending it here, msg.value, right? The amount of pool tokens that we've sent, or native tokens that we've sent along with the call. We're going to do the same thing here, right? And we're going to forward all of the ETH, all of the pool, the native token that we've got. We're going to forward this on to the router contract, and that's going to get put into the liquidity pool, right? And so then the liquidity here, right? So this call add liquidity ETH is going to have multiple return values. Here, 3 of them. I forget what all of them are. I think the min amounts right here also get returned. So we don't really need this, but we do want to return the amount of liquidity token that were the LP tokens that were minted. So we're going to return that. Right? And this is going to be the last value in the return values of the add liquidity ETH function. Right, so the amount of LP token is returned, and then we return this, right, the return value of this function. We return it along with the address of the new token as the return value for deploy token. All right, so that's it. Fairly simple function. Right, we deploy the new token here, log an event. Technically, we might want to move the log to after we've done all of the minting, right, to make sure that we're not broadcasting anything suspicious. And right, there we go, right? So after deploying the token, we mint the supply, part of it to the caller, the other part to the contract. Here we handle ownership of the newly minted, or well, deployed ERC20 contract. And then we finish by adding liquidity here on Quickswap and returning the key values, the address of the new token and the amount of LP tokens that we've created. We're sending this back, right, to the caller.